All right. Hey again, AP Chemistry. This is more support for Chapter 2 and their exercises. This is actually the last question of the Chapter 2 exercises. I'm going to walk you through this question. It is probably the toughest question, but it's still very important to consider, think about, and understand. All right, so I'm going to make a note and star this as tough. And it's well within fairness of the AP Chem exam, but hasn't been asked like this in a long time. So it says boron has only 2 naturally occurring isotopes. Remember, isotopes are the same element with different masses. The mass of boron 10 is 10.01294 AMU, and the mass of boron 11 is 11.00931 AMU. Calculate the relative abundances of the 2 isotopes. I want us to remember a couple of things here. Average atomic mass that we get on the periodic table is equal to the percent abundance of isotope 1 times the mass of isotope 1 plus the percent abundance of isotope 2 times the mass of isotope 2. So keep that in mind for something with 2 isotopes. This is how I would calculate the average atomic mass. Now, for this question, they gave you the mass of isotope 1, and this is just call it 1, and we'll call this 2, is 10.01294 AMU. Let's just call it that. And we have the mass of isotope 2 is equal to 11.00931 AMU. So I have that, and I have that. The question is asking about the relative percent abundances. So I have these 2 unknowns. Do I have the average atomic mass of boron? Of course we do. If I look on the periodic table and I look for boron right here, its average atomic mass of boron is 10.81 AMU. So I'm going to say, just call it AAM. I like to just shorten it with AAM. AAM of boron is just 10.81 AMU. And so now I have to figure out how to get these percentages. Well, there's something that's very important to understand about percentages. Percentages, right? Remember, x over 100 is equal to a percentage, okay? Well, x over 100 times 100 is equal to a percentage. So if I had, or x over y times 100 is equal to percentage, okay? Also, the sum of percentages equal to 100. So percentage 1 plus percentage 2 is equal to 100%. So percentage of isotope 1 plus percentage of isotope 2 is equal to 100%. Let's use algebra and let's call percentage of isotope 1. Let's get rid of these percentages. If I want to do that, I divide everything by 100. That's going to be 1. So let me just call this x. So percentage of isotope 1 is x. Percentage of isotope 2 is y. And that equals to 1. Okay? So let's just call x plus y equals 1, right? So I'm turning these into numbers now. A percentage is not a number. If it really is a number, it's actually the number 1. Dividing by 100, I get 1. So x plus y is equal to 1. This has to do with rules of percentages, and this may be middle school, maybe a little bit of high school. And we could revisit this if you want to go over percentages. But in general, the sum of the percentages is equal to 100. or it's equal to 1. So for example, if I had 85%, if I add that to 15%, I'll get 100%. Or 0.85 plus 0.15 is equal to 1. That's how percentages work, because I divide by 100, divide by 100, divide by 100, they will be held true. If I knew x was equal to 60%, what would be y? Well, if I wanted to figure that out, what plus 60% gives me 100? Well, 100% is equal to 60% plus y. If I wanted to figure this out, I'd have to subtract 60%. And I get y equals 40%, which is the same thing as saying 0.6 and 0.4. That equals to 1. So just a little practice with percentages here. So this idea is going to be very important. X plus y equals 1. Let's consider percent abundance 1x and percent abundance 2 is equal to y. So I'm going to rewrite all of this with the information that's given to me. I have my percent abundance is going to be of 1 is x. Mass of isotope 1 is 10.01294. Percent abundance of 2 is going to be y. And mass of isotope 2 is going to be 11.00931. So let's plug this all, and the average atomic mass is 10.81. Let's plug all of this in. 10.81, I'm going to get rid of units so you don't have to be bogged down by them later. 10.81 is equal to x times 10.01294. Okay, 10.01294 plus y times 11.00931. And it looks like I have two unknowns. This is a problem because we cannot directly solve this. But I could probably rearrange and organize this, and this is called solving a system of equations. That's why this problem is tough. It's probably a little bit of advanced algebra, right? I could rearrange this and solve for things in terms of x or y. If I want to, I could rearrange this and say x is equal to 1 minus y. X is equal to 1 minus y, kind of like what I did over here. Now I have y in terms of x, and I could plug that in here. So instead of having x here, I can have 1 minus y. So I will only have one unknown, and that will be y. So again, we have to understand percentages. You cannot solve an equation that has two unknowns. I can't have x and y. But what I could do is I could turn x into something that has y in it. This is called solving a system of equations. You may have learned this in math, or you may be learning it in math. This is not going to be big in the AP chemistry curriculum, so if you don't understand this, you're like, oh my goodness, I don't get this. Don't be too concerned with learning the rest of AP chemistry, because we will be fine with not doing systems of equations. But I still want to show you it. So now I'm going to replug this in and say 10.81 equals 1 minus y times 10.01294 plus y times 11.00931. Now let's continue to solve now for y. I only have one unknown, and that's y. Well, I could use the distributive property here, and I can multiply 10 to both of these. So I'm going to have 10.81 is equal to 10.01294 minus 10.01294y plus 11.00931y. All right, I just combine these two and rearrange it so it looks prettier. Now I'm gonna combine like terms here. Combine like terms. I'm gonna have negative 10.01294y plus 11.00931. 11.00931. And I get, if I combine these two, negative 10.01294y plus 11.00931 becomes plus 0.99637y. This is equal to 10.81. Now this looks a lot easier to solve. I got rid of all that clutter. Okay? Now I'm going to try to solve for y, just like I would be solving for x in a similar way. I want to try and isolate y. Well, I got this 10.01294 over here. Let me subtract this from both sides. 10.01294. If I do that, I got 10.81 minus 10.01294. And I get 0.79706 equals 0.99637y. And if I want to solve for y, I divide both sides by 0.99637. 0.99637. If I do this, 0.79706 divided by 0.99637, I get y equals 0.7999. Okay? Now, not quite done. A lot of work here. I know that y is equal to 0.7999. If I want to solve for x, x is equal to 1 minus y. X is equal to 1 minus 0.7999. Oops, that's off camera. If I do this, 0.7999, I get 0.2001. So now I have my answers. I'm going to flip this over. Now I have my answer, y, which is equal to percentage of 2 over 100, equals 0.7999, and x, which is equal to percentage 1 over 100, is equal to 0.2001. If I want to turn those into percentages, what do? I multiply them times 100, right? I want to solve for percentage. Multiply times 100, multiply times 100. I get 79.99 percentage of boron with a mass of about 10. And I get 20.01 percentage with boron of a mass of about 11. Sorry, that went off camera, right? So that is how you solve for the percent abundages of each of them. You first have to know your equation. You look for all the information that you have and need. You need to remember how percentages work. Then you just plug and chug. The last portion of this video is just me plugging and chugging. And so the final answers are percentage of boron, oh, I'm sorry, I have this backwards. Percentage boron 11 is percentage of boron 10. Because I said that y was going to be isotope number 2, and isotope number 2 is 11, so my bad. So boron 11 is 79.9, boron 10 is 20.01. And the boron with a mass of 11 is 11.00931 AMU, and the boron 10 was 10.01294. 10.01294 AMU. Sorry, I made that quick mistake. Right? That's why we label everything. Again, X was isotope number 1, Y was isotope number 2. And isotope 1 was 10.01294, and isotope 2 was 11.00931. Alrighty, so this is a very detailed video on question number 16. If you have any questions or concerns about how to solve question number 16 after this video, let me know. Message me in the Remind, or we could jump into a Google Hangout or Zoom to go over it again. Alrighty, hopefully this is helpful.